All right, here we're going to take a look at simplifying radicals. This is a skill that you use quite often in algebra. This is one of those skills that uh, you just kind of have to have whenever we're going to use exact answers. Um, so just to refresh here, a radical is nothing more than a square root, okay? So we're going to simplify square roots. You've seen this fact many times with me before. We've actually used this fact already with complex numbers. The square root of two things being multiplied can get split up into the square root of the first thing times the square root of the second. Okay? That is a fact that you need to know. So here's one thing, and if you need proof on this, you know, plug in numbers like 9 and 4 or something. It'll help you out. Let's take a look now. If I have how do I want to say this? If I want to simplify a square root, you know, sometimes it's nice to look at it in easier terms. And what I mean by that, like we know, for example, we know that the square root of 16 is just simply 4, right? But what about the square root of 32? You know, the square root of 32, just because I doubled the 6 does not mean that it's going to be 8, right? Because we know that the square root of 64 is going to be 8. So when I look at the square root of 32, in my mind, I'm thinking, well, that can get broken into 16 times 2. And then I can use this fact, right, to split it into two things. I can split that into the square root of 16 times the square root of 2. And we know that the square root of 16 is 4. So 4 times the square root of 2. So we left 4 square roots of 2. Right, so ultimately this is what we're going to be doing. We're going to reduce or simplify radicals that are not nice. They're not pretty. So before we go and do a whole bunch of these, one thing that is helpful to do is know what all the perfect squares are. Like we know 16 is a perfect square because that's 4 squared. So my suggestion, and I'm not going to do all this with you, but make a chart. You know, 1 squared is 1. 1 times 1, but that one's kind of useless when it comes to simplifying radicals. So we don't use this when simplifying radicals. But 2 squared is 4. We will use him. 3 is 9. 4 is a 16. You know, having these numbers handy is very helpful. I'd go all the way to 20. You know, 5 is 25. 6 is 36. 7 is 49. 8, 64. 9 times 9 is 81. 10 times 10 is 100. All right, go all the way to 20. Go all the way to 20. You can use a calculator, it's fine. But you want to have this list of numbers at your disposal because we're going to get some crazy looking numbers, and we need to figure out which one of these numbers, which one of these perfect squares we can pull out of it. Okay, so let's take a look at a few examples of this. And what I'm going to do is I'm going to I'm going to keep that list off to the side here. All right, so okay, come on now. Get it together, Stevens. All right, we're back. We're back. Okay. So simplify the following radicals. So take a look at the square root of 252. What perfect square goes into 252? Well, to be honest with you, it's not obvious. So what I do is I get my calculator out. Wait, did you hear my Texas come out? All right, so 252, I'm going to go ahead and divide that by 2 to see. Is 126 a perfect square? No. 252 is divisible by 3, so 252 divided by 3. Is 84 a perfect square? No, it's not on my list. So 252 divided by 4, 63 is not on my list. 252 divided by 5 is not it. 6 is 42. That's not it. 252 divided by 7 is 36. Okay. Now, 36 is on my list. So, and it's 6 times 7. So, square root of 252 is the square root of 36 times 7. And I could break that into the square root of 36 times the square root of 7. So the square root of 252 turns into 6 times the square root of 7. So 6 times the square root of 7. And we're done. That's as simple as I can get. So the square root of 252 would be 6 roots of 7. And here's what's really cool, just to prove to you guys. Square root of 252, 15 point blah, 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 blah. 6 times the square root of 7. Samesies. They're the exact same. Oh, that's so nice. Okay. All right, so we can show that those two indeed are equal using the calculator. All right, so the square root of 8, this one should be a little bit more obvious, right? Because we know that 8 divided by 2 is 4, right? And 4 is definitely on our list. So here we get the square root of 4 times 2. And the square root of 4 times the square root of 2. So the square root of 4 is going to reduce. We know the square root of 4 is 2, so then we get 2 roots of 2, and that would be as far as we could take it. So the square root of 8 is the exact same thing. So simplifying the square root of 8, we get 2 roots of 2. All right, let's take a look at a couple others. So the square root of 150. Thinking on our list here, we're going to try and be smart about this. What number in the perfect squares would go into 150 nicely? And the only obvious one, 100 is too big, right? 100 times 2 wouldn't do it. So the only other obvious one would be 25. So let's see what happens. Let's take 150 divided by 25, and we get 6. So the square root of 150 turns into the square root of 25 times 6. Now I'm going to break that into 2. So I get the square root of 25 times the square root of 6. Square root of 25 is just 5. So then I get 5 square roots of 6. Let's take a look at another one, 147. This one is not obvious. I have no idea what that one's going to be. So can I divide 147 by 2? No, because it's got a 7 on the end. So I'm going to start. I'm going to do 147 in my calculator, and I'm going to divide that by 3. Ooh! Woo, 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 woo. Hang on. 49's on my list. Yes. So the square root of 147 turns into the square root of 49 times 3, which is the square root of 49 times the square root of 3. And the square root of 49, as we saw, the square root of 49 is 7. So we get 7 roots of 3. And that is how you simplify radicals.